Now comes the fun part. We can start running the API to see how things are working. Notice the map group parameter in the endpoints class. It's API author. Then each map method appends the relevant query string that's expected for that particular method, such as a slash with an integer that represents an ID to search for. When we ran the app before, remember that it defaulted to Swagger's user interface. But for looking at the GET methods, it's a lot easier to just browse directly to the API author URLs. So I'm going to change the launch settings that Visual Studio reads, and that's a file in the Properties folder. Since I'm running the HTTP profile, this section right here, notice that the launch URL is Swagger, and I'll change that to API/author, so that's the default for this first bit of exploration. I'm going to have to show you a problem and a way to fix it that will hopefully be fixed by Microsoft by the time you're watching this course, but you need to see it just in case. When the API attempts to execute the query, it will throw this message about invariant culture. This is happening because of an overzealous attribute in the Web API template. You can see it here in the CSproj file for the Web API. It's this invariant globalization attribute that's set to true. In the near future, this won't be the default, so you can change it to false or comment it out or just delete it. And that's perfectly fine for the demos we're doing. But I did want you to see the error so that you'll recognize it and not freak out if it happens when running the demos. Okay, now let's run through this thing again. Much better. Since the endpoint is only querying the authors, not any of its related data, the author objects are only coming back with the ID and the first and last name populated, and the books property will always be empty. Remember, I said that logging has a few default targets for its output. Looking at the debug output window in Visual Studio, you can see the command that EFCore sent to the database, although it's buried among so much other debug information that isn't coming from the logging. When debugging by way of ASP.NET Core's server, as I'm doing here, ASP.NET Core also outputs logs to a console window. And here's that window. Recall that app settings had some other default logs set up, and that's why you see this hosting info at the top. But then we've got all the warnings from EFCore, as well as the database command that was sent to the database. Showing the logs in a console window is important if you're using something other than Visual Studio on Windows to build and debug your application. It's also possible to see the logs if you choose to debug against IIS Express, and those will show up in a Visual Studio debug window. Let's get back to the API methods. The default is that GET that returns all the authors, which, remember, is how it was defined by the template. The other GET method allows you to pass along an author ID to just get that one author. The code queries for that author using first or default async with no tracking and searches for the author with that ID. Remember that find and findAsync methods do execute right away and don't represent queries, so they can't be combined with the asNoTracking method, and that's why the template uses first or default instead. However, because the service that I set up for pub context will always disable tracking, you could use findAsync here, but generally first or default can still be more efficient in the long run. My API is still running. I'll toss a breakpoint in there. Now I'll just tack a slash and the number 1 at the end of the URL and hit enter. The code queries for that author along with the ID that got passed in. The code then ensures that you did get an object back, and if so, it returns that object along with a 200 OK HTTP status code. Otherwise, it returns a 404 not found code. But we did give it a valid author ID, so we get the result back. Let's see what happens if I use a bogus ID. I'll use 123, which I know isn't in the database, and the output of that is a 404. There's one last thing I want to do here, which is to show you that you can certainly return shaped results, but you'll have to add code to handle the recursive data that comes back in the results. I'll modify the getAllAuthors mapping to include books along with the authors, and then I'll run the app again. And we've got an error. The most important phrase in this exception is a possible object cycle was detected. And you might recall learning in an earlier module how the objects for related data are cyclical. I mentioned at that time that this causes a problem with web applications, and this is the exact problem. It's not an EF Core problem, and it's not an ASP.NET Core problem, but just a software problem. ASP.NET Core is converting the results into JSON, and as it's doing that, it's tumbling into the cyclical data, and then eventually it just decided there were way too many levels. Because it's so common, the error also tells you how to fix it. It says, consider using reference handler preserve on JSON serializer options, which we need to apply in the program file. To do that, we'll tap into another service, this time configure HTTP JSON options. This takes a Lambda where you define the options, serializer options, reference handler, and apply a value which is coming from an enum. The error suggested the preserve enum, but that has a side effect on how the JSON's formatted, and it can be a little startling if you happen to look at the JSON output. Every JSON object is encapsulated in what I call a super JSON object, each with their own ID. These super objects have nothing to do with our database data or our entities, and the entity objects themselves are still deserialized correctly. Regardless, the better enum choice here is ignore cycles instead of preserve. And with that, now when I run the API again, there are my lovely authors and their books. The only other change I would make is going back to the mapget method and modifying its name in the with name property to explicitly reflect what the method is now doing, so get all authors with books. As I said earlier, the template created a decent stake in the ground, but most developers working with ASP.NET apps might either skip the template completely or immediately do an important refactoring. Using the entity classes directly from the back end all the way to the front end is considered to be an anti-pattern. And now that you've seen the basics of how the template-generated controller works, it's time to refactor it to keep the entities out of the requests and responses from whatever client is communicating with our API. And there are even more ways to improve on the design when your endpoints are using EF Core, but this will be a reasonable start for your EF Core fundamentals. The classes we'll create for the HTTP requests and responses are called data transfer objects and fondly known as DTOs. And because our original classes are pretty simple, the DTOs here won't look much different. However, it's still important for you to understand how to use DTOs with EF Core in the mix. The way this will work when we're done is that we'll use the original entity classes anytime the API interacts with EF Core for queries, inserts, etc. But when we work between the API and whatever client is making requests and receiving responses, that will always use a DTO, which means that these API methods will need to be able to transform entities into DTOs and back. I'll start by creating a DTO that represents how we want the author data to be surfaced from our API. I've designed the DTO so that the properties can only be set with the constructor during initialization. That way we'll never get a partially populated DTO, and it will be a little easier to use in code. The author DTO will live in the Pub API project because it's specific to the API, not any other part of our application. But if I were building a front end, I would also include these DTOs there. And again, this DTO looks similar to our author class, except that it's unaware of books. That means there's no need for the author DTO to have a books property. Otherwise, it does look similar with the author ID, first name, and last name, and it has a few more constraints built in. Let's see how that affects the mapget method that gets a single author. First, I want to make a change to the query string for the getAllAuthorsWithBooks method, so there are no surprises. Instead of this showing up by default when someone might be expecting only authors, I'll modify the route with the explicit term with books. Now the current state of my API is that just calling API/author doesn't return anything, but API/author/with-books gets the result described in the endpoint. Now let's look at the getById endpoint. First, I'll change the expected type that's going to be returned with the HTTP result to be an author DTO. And as I expand the method, you'll see I've already applied the rest of the modifications. The query is now using a select method to project an author DTO from the relevant properties of the author. And rather than have the filter on author ID as the parameter of first or default async, which it was originally, I've extracted it and put it inside of a where method. And the reason is that I need to apply the filter on the author, and I can't do that after the select statement, or it will create a problem for EF Core when it attempts to build the query. And in that last bit, rather than verifying that the resulting model object is an author, I'm now checking that it's an author DTO, and that's what will be returned along with the OK result. I've set a breakpoint on the line that returns the author DTO, and I'll go ahead and run the API. Remember, my launch settings still default to API author, so that's still not working. But in the URL, I'll just add /1 to the end, and now here I am in the get author by ID endpoint, where the model object is the author DTO. And here's the output from the method. Because it returned the author DTO, I no longer have that always empty books property. I've also refactored the other endpoint methods. We'll explore those as we debug them.